So this bit is about what is maths. And I can appreciate that looking at what is science isn't the same as looking at what is maths. Right, here's the thing that I've got for you to have a go at. I think this is a maths task. I think it's also, well, it's up to you to decide that it's a science task. I am convinced that it's a maths task. This is where you're going to need your paper, and you're going to need to work in pairs, and you're going to need table space. So we're going to have a challenge. Okay. I don't do answers, by the way. I'm not going to tell you the answers. You know whether you're right or not. Right. So I've just been having a conversation with a few people. The questions are, okay, I'm convinced this is maths. See, this is the problem with these things. You are like mathematicians. When you get one of these, you're not going to stop until you've done it. I'm convinced that this is maths. I'm not sure whether it's science. I think that when I looked at the Key Stage 3 curriculum, I thought I saw something about basic knowledge of the solar system. But I might be completely wrong. I might have the wrong curriculum. But the point is, for me, right, where's the maths? And if there is science, what is the science? Do you want to just have 2 minutes? What maths is there? And if there is science, what science is there? You talk better than mathematicians, so we all just sit and look at each other's shoes. Right. Is it science first? Is there science happening here? Some people have said yes, some people have said no, by the way. Right, so is there anybody who's going to say yes, there is science? Anybody prepared to say yes, there is science here? Somebody over there is saying yes, there's science. Yeah? Go for it. There is science. So what is the science?
You have to know the solar system before you can do the maths. Okay. And that's what I found interesting about it.
Okay. Yeah. So
you've got to have done the scientific observation to get the information to actually solve this puzzle.
And it's not science because...
Well, it's not so much that. I'm not sure that I just could do that because I can read and my brain is a natural problem solver anyway. I'm not sure I did actually interpret much about the solar system, particularly when I was trying to work out the clues, because I was more interested in Pluto. Where's the next thing that says Pluto? It wasn't that I knew Pluto was at the end of the solar system particularly. Does that make sense? I wasn't really using my solar system knowledge. I was just trying to problem solve by knowing my English.
You have to know the order of planets. You can't do it without knowing the order.
No, that's true. I did write that down first.
And you have to know that Earth is a planet because it's never mentioned.
Okay. Well, that's true.
I don't know, science isn't especially demanding anyway, is it? The sequencing of planets, but I actually found it quite. I don't quite have your logic skills. I actually found it quite taxing, following the instructions, working out where the instructions were in amongst it all, and I actually quite enjoyed it.
And that's really interesting, isn't it? Your ability to interpret your logical thing. But you're right. I did write the planets down first. I'd forgotten that bit. Little mnemonic.
Yeah.
Go on.
I had my prior knowledge of Earth being a planet, and I knew my 9 planets or 8 planets and a bit. And there was some additional information in these cards that if that was all I knew, there was additional information there. But I was so excited about solving the problem that was, like you said, a literacy thing. It went in my eyes and out the other side. I didn't retain those facts. I don't think I would have retained those facts if they were new to me, because I was engrossed in solving the problem, not taking on new knowledge.
Yeah, I was going to say similar thing, that it did sort of help consolidate some of the science to me, but I don't actually care about the science, I just care about finishing. So if I did it in a science lesson, I wouldn't be confident that the students would be really learning the science and just wanting, like in maths, just to get the right answer.
But I use these are really, I'm not saying they're common, but they're becoming more common. This type of activity is becoming more common in maths classrooms. Because the process of solving it is what I would call mathematical thinking. Somebody has said that they would call it scientific thinking. Maths is just the queen of all sciences, so yeah. I've got a desk between me and you, it's okay. But there is that logical deduction. This is what mathematical thinking is about for me. Whether there's science in this, we've got, as part of the maths across the curriculum strand at my school, we've created some of these for various things. We call these mysteries, and we have, of course, a history mystery, because why wouldn't you? We have an RS mystery, we have a DT mystery, and so kids are meeting these in their subject areas. We're finding them quite useful for that thing of revising. You know, basically, they're not going to teach you new knowledge. You're not going to learn the order of the solar system through these things. And you're not going to learn facts about gas giants necessarily through these things. But the idea of using them to revise, to refresh kids' heads, 10-minute, 15-minute starter. The first time you do one of these with a group of kids, there will be absolute chaos for about 5-10 minutes as they go, huh? How do you start? What do I have to do? I don't know what to do. And you need to sort of sit back and let the chaos happen. And then somebody will go, oh, hold on, it says here I have to draw a grid. And then then they start to go. And then after about 20 minutes, everything's quiet. But there's this thing about knowing what to do when you don't know what to do, that thing about getting unstuck. And so we use these a lot. I use these a lot in maths. And it's that thinking process, that problem-solving process, the idea that, and we get this in maths, and you must have this in science. Kids want to know the route through the problem before they start the problem. They want to know every step in the way. Yeah, does that ring true? And you can't do that with this. And that's, for me, it's one of the big powers of these types of activity, is that you don't know, so you have to take that leap of faith and take a punt and say, it's this is true. Right now I need to find the next step. Because it is just step-by-step problem solving. We're getting to what is maths, by the way. What's this? Right, go on, be precise for me. Music.
It's a notation for reproducing.
It's musical notation. Is there anybody in here who does music who can have this can play this in their head? Yeah? It's One Direction. Oh yeah.
How do you find music?
Does anybody know what this is?
It's dance, isn't it?
First person ever. Yes. This is called Lyman notation, and it's dance notation. It's read vertically. Don't ask me any more than that. It's read vertically. This one? Okay, this one is juggling notation. And this one, maths notation. Maths notation, not maths. This is the bit that I really want to get to, okay? This is not maths. This is maths notation. Musical notation, yeah? This is a record of something that has happened and some instructions for something to do. It's not music. If you can read it, this is dance notation. This is instructions for dance. It's a record of dance. This records something that's happened and lets you know what to do. Same. This is a record of some thoughts that have happened. The difference we have is that with maths, it doesn't notate anything other than thought process. You can't connect this to a movement as you can with the dance notation, or with the sound as you can with the music notation. The only record we have of maths, which is what we do in our head, is the maths notation. It's the only way we can communicate it. But there is a distinction between the maths and the notation that we use to record the maths. And very, very often, the two things get muddled together. And so we think that we're doing maths if we're using numbers. That's maths. If you're doing numbers, you're doing maths. If you're thinking mathematically, you're doing maths. If you're writing numbers down, you might just be following a recipe. You might just be doing whatever. You're not doing maths. I should say this is my opinion, and against you a little bit. But this is, yeah. So Right, so my big push for you in terms of maths in science is to give kids opportunities to do maths. Not numbers, not play around with numbers necessarily. Well, maybe play around with numbers, but to think mathematically, to give them an opportunity to work out what they have to do. Okay, and so I've got some examples where we'll look into this now with some calculations and that sort of thing. But it's about the thinking process. It's not about getting the answer. So with this activity, the solar system activity, you were doing the maths. Whether you finished it or not is kind of irrelevant to the maths you were doing. It's nice to get that sense of closure. But the maths was in the thought process you went through, not the answer that's written down there. Does that make sense? Oh, good. So that's the first bit, the what is maths bit, almost bang on time. So what I want to do now is just look at some calculation strategies, some gadgets, some things you might do in a class to support your kids in doing maths. Can you do that in your head for me, please? Don't write anything down, just do it in your head. Okay, and then when you've got there, or near, talk to the person next to you, because you didn't just go, oh, 13, 16s are, blah, blah, blah. He says, hopefully. You broke it down somehow. Talk to the person next to you about how you broke it down. Pretty much everybody I've talked to has got 10 16s and 3 16s, yeah? Yep. There are people who did different things though. Some people did different things. Did anybody do 10 13s and 6 13s? Yes. Okay, good. Go on, I've got to ask you to explain your method.
Right, so, sorry, mine.
No, go for it, in the check.
Went to times table, so I thought, okay, right, 16s, don't know that, but no 8s. So, and then thought, we'll change the 13 into 12, so 8 times 12, double it, and then add the missing bit.
Did you have a...
No, the only thing that I did 10 13s and 6 13s, but I didn't do 6 13s because I know that 3 13 to 39, so I did 2 lots of 3 13. Yeah. So that's how I
anybody 13 13s and 3 13s? Yeah, 13 13s and 3 13s. There's usually one. I use this calculation for this quite a lot because there's lots of different ways. The point is, okay, when we do this in schools, in classes, there's a habit because a kid will say, I don't know how to do 13 times 16. And you are a good teacher, you don't just say, well, the answer is. You ask them a question, usually, yeah? And so you'll say, well, what are 10 16s? Or what are 13 13s? And they're going, but I'm trying to work out 10 13s. Why is he asking me, or she asking me about 13 13s or 10 16s? And what we do is we know the way that we want to do it, and so we ask a question that drives them down that way. But they're not necessarily thinking the way that you're thinking. And so your question, which is designed to help, actually just makes them go, what are they on about? Oh my god, I can't do maths. This is ridiculous. Yeah? And so the first thing you need to do, I would say, is when you've got a kid trying to do a calculation, just say, how are you doing it? What are you trying to work out? And let them give you, you're good at maths. You've got flexibility in your thoughts, so let them ask you. If they're stuck on 13 16s, let them tell you what they're trying to do and see whether what they're trying to do is sensible for whether they're trying to do 12 16s first. No, not 12 16s, but 12 8s. But, you know, it's listening to them. You need to listen to their methods, listening to their thinking. It gives them a chance to think, it gives them a chance to think, and to think mathematically. How am I going to solve this problem? How am I going to break down 13 16s into something that I can already do? Yeah? Oh, good. Okay. I'm going to take a little aside just to show you something. How many dots? You can't see. You know, I'm simply showing you this because I know a lot of maths teachers who didn't know this came from that. You know this method of multiplication?
Yeah.
It comes from that. And there are loads of maths teachers who don't know that, and I figured if maths teachers don't know it, then it's quite feasible that you guys don't know it. It's an area. It's just an area. Now, kids now, in the new maths curriculum, are going to be driven to column multiplication. Okay? They might get it right, they might get it wrong. I don't know. It depends how good your primaries are at teaching column multiplication. But having an understanding of where it comes from is quite helpful. And it's just an array. It's an array of dots or an area model. Yeah, it's just breaking it into sums that you can do. Often when I do the 13s, 16s, I do this little bit. Is a direct lift from a session I do with parents at school. And usually somebody will go, I did, 10, they do like this bit and this bit. So they do 10 tens, and in this case they do 10 tens and 3 sevens. And miss out these other bits. And this is really nice at explaining why you can't do that. Okay? But just to give you this idea of why multiplication works, why this works, it's an area model. You've seen this, yeah?
Yeah.
You know this. Okay, good. Right. I'm a little dubious about this next thing. Right, the next slide is a speed challenge. You have to copy down what comes up and answer it. Okay? It's copying it down and then answering it. I hope it's above the line that you can see. Yes. And when you've got it, keep quiet, please. Cool. Okay. Quite a few people have done. Is it working? Yes. Have done that. Yeah? There's no need to do that. I'm willing to bet that I've done this with loads of teachers, loads of mathematicians, loads of people. If you're good at maths, what you tend to do is go, you don't even read it. This is an invitation to a method. That question is a method. You don't read the question. You just go, I know what to do here. It's 7 take away 8, I can't do that, and then you start crossing out. And everybody does it. Not everybody, loads of people do it. By writing the calculation in this way, we're not saying here's a question, we're saying here's a method and I want you to follow that method. All you need to do is write the question like that. Whoa, you can't see it. Down here, it's written in a line. Down here it says 4007 take away 3998. And if you see that, people go, oh, it's 9. I have a friend who saw a kid question once, and he said they wrote down this. 16 take away 9. 6 take away 9, I can't do that. 16 take away 9. But it's this idea that we give, there's a method, this is an invitation to a method, yeah? So strategy number 2 for maths, in science, for maths anyway really, is don't write down a method or a question that's just a method. We do the same with division, yeah? If you're doing division, you're probably going to write, or whatever, as division. It's a method. It's not a question, that's an invitation to a method. So if you write it as if you write it like this, then there's a question there, and kids can use the method that they want to use. They might well then go to column. They might do that. But they'll have an opportunity to think mathematically, how am I going to do that, rather than follow a method that they are essentially being given.
Is there a challenge though as a science teacher that if they're thinking mathematically isn't maybe that good, but you're not a maths teacher, so you're not quite sure how to then help them out?
Yeah.
And I'm not saying your thinking wasn't good, but that example of a child thinking in a different way to what you're doing, but you're not the maths teacher, and you don't know the maths techniques because we're not trained in those techniques. Is there a danger then you can change that child's way of thinking, or damage that child's way?
I don't think you can damage it. I think that's okay. I think to say this is a different way, this is the way that I would do it, is perfectly, it's fine. Have kids having a flexible set of images and flexible set of strategies is fine. But kids, you know, it's that thing that if you listen to them, odds are they're not going to have something that complex.
No,
Or
well,
it
I
might
thought that
be.
thinking, that I wouldn't have challenged that thinking as a child. Once they got to the answer and they could work out,
Yeah.
then that would be it for me. I was like, yeah, whatever works for you. But if they're not then right, how do you know you're intervening correctly? I think that's probably.
I think just say, you can explain it to me. What do you know that might help you? Let me press the button. It's basically these two questions. What are you trying to work out? How are you trying to do it? What do you know that might help you? They're the key questions, really. And they will find their own way. If it's division, for example, I should have put this on the slide. If it's division, there's two ways of thinking about division. You can think about division as sharing, having a quantity and sharing it out, which is quite a hard image. Or you can think of it as how many of these things are there in that thing. So 6 divided by 3 is 6 sweets shared between 3 people. It's also how many 3s are there in 6. And if you ask how many 3s are there in 6, there's an implicit structure there. I can start to count. If it's how many 3s are there in 628, I can still start to count. It's not going to be efficient, but you can still do it. You know, it's giving them a way in. So, yeah, I don't know if that answers your question.
Is that perhaps why they don't find tables of results very satisfying and useful? And it depends which way round you draw them. I was thinking about, say, titration results, where you're trying to take one volume away from another, and you make sure they put the decimal points underneath each other, but you're actually driving them to a method. Whereas I've seen some that write it the other way round and pivoted their table because they're going crossways with their numbers.
I don't know about what the table might look like, but yeah, I think that giving them the opportunity and something else that is a nice way of encouraging kids to think mathematics is to say, I saw this lesson, maths teacher, it's a very standard maths lesson. I was like, oh, this is fine, sitting at the back of the room, throw some dice, record the number of 6s you get, or record the results each time. So rolling 2 dice, record the results each time. And then she said, and this just lifted it massively, she said, and I want you to think about the best way to record your results. And that was it. And the kids were like, so some kids, 2 boys, just had a list of numbers, which was ridiculous. After about 3 minutes, she stopped the class and said, I've been looking at these results, these tables, and somebody's done this, and she held up a nice table. Somebody's done this, and she held up a list of results. Somebody's done this, and she held up something else. Which of these is the most efficient way of recording the results? And it gave them an opportunity to think. Fact free, right? They might not call it this, but this is sort of a primary school strategy that they will have. If you know this calculation, there's the answer to the previous one, by the way. You also know these, without having to do any thinking. You know this. Yeah, you don't have to think. Can you write down 3 other calculations, please, that you know the answer to? Based around this, not just random calculations. Right, I know you know how to do this, so I'm gonna. Can you write down 3 other things that you know based around this, please? Again, I know you know the answer, okay? The point is, this uses a relationship that exists.
No, I can see.
I hate them. Okay, I hate them, but I know that you're going to use them. I know that, you know, and I know that your maths department might use them. Some maths departments use this idea. But I think giving them this versus letting them arrive at this, I'm not sure, right? Going from this, because kids know that 2 times 3 is 6 and can then write down 3 sums. If they know this thing, and remembering that is no harder than remembering this, I don't think. They can also write down 3 things. And what they've got in doing this is they've got a relationship that they're thinking about. They've got an idea that they're thinking about. I know, I've worked with kids, I don't know if this echoes with you, where they've had something like a car travels 30 miles in half an hour. How fast is that car going in miles per hour? And they've written down the speed distance time triangle. They've written 30 here, they've written 0.5 here, because they were quite good. And then they've tried to do, divided by half is hard. So they don't have a sense of the relationship. They're not thinking about it, they don't have the relationship, they're plugging it into, you know you were saying the chemistry set's a recipe. They're plugging it into this recipe. Not doing the maths, not thinking about the relationship. So they know that they have to use this, they go to the gadget. If they were able to, I think, they're more likely to spot the relationship if they have this and they can build their other formulae from it. It's about exploiting the relationship. And a really nice strategy for that, this is by a guy called John Mason. He uses this idea of particular, peculiar, general. So pick a question that they can do. Particular case. Let them see the relationship. Yeah, 7 times 8 is 56. Write down the other facts you know for free. Then say, write down a crazy one. In this case, I did this. This isn't so crazy. Give this to year 7 boys and you'll have 28 zeros. And they will do it. And boys will love writing these nuts things out, particularly boys, it seems. They'll write down something crazy and they'll test it. And they'll test it with a weird number. If it works with a weird number, there's sort of another step towards believing it as a general case. Then give them the general. But so this is for rearranging formulae, because Key Stage 3 formulae, you don't get much beyond this, do you? This sort of idea. I was in a school a couple of weeks ago, and there was a poster, I nearly put it on the wall and I thought I'd get in trouble. And the bulk of the poster said, "That's Peter Andre." And there was a picture of Peter Andre looking fat. And then underneath that, there was a triangle that went F, P, A. And then in tiny little letters under here, it said something about force, pressure, and area. And the bulk of the A3 poster, about that much of it said force, pressure, and area. And it was, for me, there wasn't science in this. There wasn't maths in this. This was just about remembering a thing. And whether there was a relationship there, whether they understood a relationship, whether they had any ideas, I don't know. Oh, I'm running out of time. You've got 2 minutes just to get a flavour of this. So I'm just thinking this sort of thing. And I use cards a lot. I like cards. Cards are nice. You don't have to use cards. You don't have to cut out cards, certainly. I did this because I thought you'd like it. But you know, kids are remarkably adept at cutting things out if you really want them to. My lot with those mysteries, they don't even bother cutting them out anymore. They know how to do them. Yeah, you go. And anybody else? Just what about sorting these into groups? You've got what goes together. See what goes together. Right, so, essentially, pretty much done. This thing that I've just given you, there's this, again, the idea of different representations of relationships, different ways of thinking about something. Quite a big thing in maths. Encouraging that flexibility of thought, and again, so I'm suggesting that you're encouraging some mathematical thinking and focusing on the relationship with this. Missing some out is quite a nice way of doing this and getting them so that they don't feel too comfortable. Okay? It's quite interesting to see kids who suddenly find that they've got a card left at the end and watch them panic. With their sort of, I don't know what to do with this. So in the world, you don't know that you finished necessarily. You know? So I think that's quite nice, and then get them to create something. If they can create their own set. Often I'll do this on a bit of paper, fold it into 16 pieces, scribble on it, photocopy, pass out. Strategies then. Representing mathematically on these things. Give kids opportunity. If you're using averages, I'm not sure that you would, but I put it on here. Ask them what type of average. If you're using graphs, ask them what type of graph. If you're using timelines, remind them that it's not to scale, necessarily. If it's not to scale. I was in a museum yesterday. Oh, I struggled. There was a timeline on the wall. Here it was like 1983, here it was like 1942, and here it was something like 300 million years ago. I'm like, oh! And it made me panic and worry. And this is a really nice museum. But for me, it just needs a little word that says not to scale. I don't know the timelines, but that sort of idea of just if there's a proportional relationship, if you're representing mathematically, represent it mathematically. Draw out the maths, let them decide. How long is your timeline going to be? What table are you going to use? What type of graph are you going to use? What type of average are you going to use? So, my key strategies, my things to take away. Ask how they're going to tackle the problem. How are they trying to do it? Let them work on a problem rather than work through a problem. Okay? This idea of driving towards an answer. Yeah, you've got to get to the answer. That's not, you know the answer, you don't need them to work it out for you. Yeah, the point of them doing the activity isn't to get the answer, the point of them doing the activity is to learn something, not to go away with the answer. And focus on the relationship and generalizations within a thing. Peculiar, particular, general is a really nice strategy. And focus on the mathematical thinking, point it out to them. Ask them things like, is that the most efficient way? How do you know? How are you going to collect your results? How are you going to gather your information? Structure your time. If there's a project work, how do you know you'll meet the deadline? What type of graph? Is it biased? It's 3 o'clock on the dot.